In this video, we're going to look at the cost function as applied to calculus. Cost functions come from economics. Here, we want to know what is a cost function, who is incurring the cost, and what are the different parts that make up cost functions. So, a cost function, which we typically denote as C of Q, is going to be the cost of producing some quantity of a good. So the cost, when we talk about cost function, is the cost incurred by the manufacturer or firm producing an item or a good. So when we think about that, we're thinking about it from a supplier standpoint. If I'm making something, how much does it cost me to produce this thing? C of Q, the C represents cost, and Q is for quantity, because the cost is going to depend on the number of items that you make. So cost has two parts that are part of its full equation. One of the parts is called the fixed cost. Fixed costs are the costs that you're going to incur even if you don't make anything. So, for example, if you're going to open a company and you decide to buy a building in order to manufacture your goods, that's part of your fixed cost because you're paying for it before you even made anything. The other piece is the variable cost. The variable cost is going to depend on the product you're making and how many units you produce. So if you're opening a building so that you can manufacture clay pots, one of the variable costs will be clay, because the amount of clay is going to depend on the number of pots you're making, the quantity. So that's a variable cost. Now, in economics, these types of equations can be really simple or really complex depending on the item that you're making. For our purposes, we are only going to consider linear functions in this section, and as we develop more intuition, we'll move on to more complicated cost functions. So one of the things that you're going to hear in terms of terminology is the term marginal cost. In economics, we often ask how a product is impacted at the margins. So the question is, how much more is it going to cost me to make one more of my product? So this idea of having one additional unit is called marginal cost. So when we talk about marginal cost, we're talking about the variable cost for one additional unit, because the fixed costs are fixed. Those are going to be the same no matter how many you make. So really only the variable cost is impacted. We're going to be looking at linear functions, which is where we start our analysis in this course. And so for a linear function, the cost function is going to have some sort of positive slope as we go up, and the slope of that line is the marginal cost, because the slope is going to tell us how much we change in the dependent direction for one additional unit in the independent direction. So for a linear cost function, the marginal cost is the slope of our cost function line. So we want to make sure we're in the right mindset when we're thinking about cost. And so what we really want to do is we want to look at just a couple of examples to make sure that we understand what this looks like both graphically and how to put it together in terms of a function. Example 1. Considering the two following scenarios, and draw a graph of a linear cost function satisfying the given conditions. So again, right now we're considering cost functions that are linear, but in business, they don't need to be linear. But we start with the linear case so we can build up the intuition of how they work and eventually get to more complicated cost functions. So for part A, the cost function that we want to draw is going to have fixed costs that are small and marginal costs that are high. So think about a linear equation and think about what the fixed costs would represent. So the typical equation that we use for a line is y equals mx plus b, right? A cost function, our dependent variable is c of q, is mq plus b. Okay, the difference here is I swapped out the names of the dependent and independent variable just to match it up to our thinking. So the fixed costs are our costs even if we produce zero quantity. So if Q were to equal 0, that would leave us with just B, right, which is our vertical intercept. So if fixed costs are small, that tells me that my vertical intercept is small. And so if my vertical intercept is small, that means I'm pretty low when I cross to the vertical axis. So we don't have an exact value, but we want to be somewhere in the lower range, maybe somewhere between 1 to 5. Now, marginal cost is high. So remember, we said the marginal cost is our analysis on the margin, or what it would take to produce one more, which is the slope. So marginal cost, which is slope, being high, means that our M is large, which gives us a steep line, right? The bigger your slope, the steeper your line. So we want a line that starts off somewhere low, our fixed cost, but increases very, very quickly, okay? So this is a line that intersects at 2, but has a pretty high slope given the conditions. So this would be an example of one way that we could draw something with a fixed cost that is small, but a marginal cost that is high. This is definitely not the only way we could draw this. There's several ways we could do this. Another one might be something like this. That's still pretty high. Fixed cost small, we can make the slope even steeper, right, and go through at 3. These all tend to have the fixed costs are small, marginal cost is high sort of idea to them. So any of those would be fine, but the idea is that our fixed cost crosses through the vertical axis really low, and that the slope of the line is pretty large, which means it should be at least more than what you would get if you had a slope of 1. Let's look at another scenario and see if we can draw it. So for scenario B, there are no fixed costs and marginal cost is small. So if we have no fixed costs, that means that our B-intercept is 0. So we're starting down here at 0, 0, right? Because we have no fixed costs, so we will intersect at 0. If marginal cost is small, remember marginal is talking about the slope of this line, M. So our slope being small means that we're going to have something that doesn't go up very quickly. We're going to stay pretty low. So we want something maybe like this. Pretend that that's a really straight line. So we're going to keep our slope really, really low. Again, this is not the only way we could draw it. We could draw it a tiny bit steeper. That's still pretty small. Or we could try to draw it even less steep than that, right? But all of these have to go through 0 because our fixed costs are 0, and we want to keep the slope really low, so it's not going to grow very quickly. So that's our example B here on how we can draw that scenario. Let's look at another example. Example 2. Suppose a company produces ceramic pineapples. Okay, so that means we're going to be making and shaping ceramic pineapples, and we're going to be talking about all the costs that goes along with that process. The cost to purchase the pineapple molds and the kiln, which is a giant oven where you fire your ceramics, is $20,000, which are incurred even if no pineapples are made. So this idea that this is going to happen as a cost even if we don't produce anything, these are the key words that are talking about fixed costs. So this $20,000 is a fixed cost. Okay. The cost of labor and raw materials are variable costs since these quantities depend on how many pineapples are made, right? So the amount of work that you need to do and the amount of raw materials you need to buy depends on if you're making 1 ceramic pineapple or 1,000 ceramic pineapples. The variable costs are $6 per pineapple. The word per is also a key indicator. That's a word that tells us that we're talking about multiplying things together. So here, that $6 per pineapple helps me understand that it's related to the quantity. So again, for now, we're assuming that cost is linear. We want to come up with an equation that models this cost function using these numbers. So You can use y equals mx plus b, but we want to get in the habit of using the variables that relate to the scenario. And in economics, we often use C and Q. C for cost, Q for quantity. So the cost equation has two parts. We said a fixed cost and a variable cost. The variable cost, we said, is the slope of the line. That is the one that is attached to our variable. So we have 6Q, so that's $6 per pineapple, plus, now our fixed cost is our B, or our number where we cross through the vertical axis. So our cost is 6Q plus 20,000. So if we were to make, say, 1,000 pineapples, we would plug in a 1,000 for Q, and then our total cost would be $26,000. Part B, determine the marginal cost and explain what it means in this context. So remember, the marginal cost is the cost to produce one more pineapple. If I wasn't 100% sure what the marginal cost was in a scenario, I could plug in, say, a 10 for Q and then an 11 for Q and look at the difference to determine how much more it costs to produce one more. However, I know that for a linear function, that's going to be equivalent to the slope. So if I increase the independent variable by 1, which is Q, I know that the dependent variable C will increase by 6. So the marginal cost is $6, and what that means in this context is for every additional pineapple that I make, it will cost me an additional $6.